Algebra 2 friends, here we are in section 13.2 talking about angles and angle measure. So we're going to talk a little bit about angles this time around. And I know you guys know how to measure angles, but now we're actually going to place angles on the XY coordinate plane. And we're going to talk about some really cool things. I think you're going to like it. You know, it's going to be awesome. Let's just talk a little bit about what we know. If I were to start off with an angle here, let me use a red line to begin the angle on the positive side of the x-axis, and I were to open it up, and let's let this ending side be blue. So the starting side is red and the ending side is blue. You know that this angle would be 90 degrees, and you would be right? That's a 90-degree angle. And let me use a better color and a better pinpoint. So let's just use black. So that would be a 90-degree angle. And if I were to open it up some more, let's say take this same blue ray and move the blue ray over to this part over here, you would know that this angle now that I'm making, if this is the first part of the ray, this is the vertex, and that's the rest of it, you would know that this angle is 180 degrees because it's a straight angle. We don't often talk about angles larger than 180 degrees in geometry. And so I can understand if you're like, where are you going with this? Because I'm kind of wondering that too. Where am I going with this? Well, what I'd like to talk about, let's see if I can erase this little blue part without getting anything. Okay, good job. So if I were to take this blue part and put it down here, now we've already talked about the fact that this part is 90, this part is 180, this would have to be another 90, therefore this angle, if I come down here, is going to be 270. So now we're looking at the whole coordinate plane in a different way. We're looking at it in terms of angles. If I continue on with this logic and I go right back to my beginning part or my beginning angle and my final ray, I said beginning angle, beginning ray, and my final ray is right on top of it like that, then I've gone all the way around to kind of close again, and I get a weirdly large angle that would be called a 360-degree angle. Okay, so this is the energy that we're going to look at the coordinate plane, and we also will look at XY. So we're going to be looking at some overlapping feature and ideas. Thank you for letting me chat with you about that. The red ray that I started off with, I'm going to put it back there, that is called the initial side of an angle. Okay, that's the initial side of an angle when we're considering angles placed on the coordinate plane. And then the blue ray that I was talking about, it could be anywhere here, just moving about, is called the terminal side. So it's the ending side. So when we talk about standard position of an angle, we're talking about placing an angle here. Of course, I could do all kinds of things like this, call that an angle, and this would be a particular angle. But when we put the angle in standard position, our expectation is to have the initial side on one side and then the initial side right here, starting at the vertex, starting at 0, 0 at the origin and going along the positive portion of the x-axis, and the terminal side ending anywhere it needs to. So then after we kind of play around with this concept and drawing different angles based on this information here, and we're going to make sure that they're all in standard position, we're going to talk about unit circle. The unit circle is this really, I don't know, I find it devastatingly beautiful. I know that sounds really overstated, but basically we're going to be talking about trigonometry as it relates to a circle with a radius of 1, okay? Hence the unit circle. So, and that circle will be on the XY axis, and so we're going to talk about some cool things in relationship to that. So I'm looking forward to that kind of discussion. So the unit circle is a circle, is that purple circle I was just drawing with a radius of 1 that we're going to use to describe trigonometric concepts. And then radians is a different way for us to consider an angle measure. It's a different way. So here's what I'm going to tell you. Let's go back to that unit circle again. All right, so we're up close and personal with the unit circle. And as I mentioned before, the unit circle has a radius of 1. So we're coming out to +1 on the x-axis, the y-axis, -1 back here. You guys get my idea. Okay, you get where we are. So this is the unit circle. And so if I were to consider an angle, like any angle that you want to think of, let's say a 90-degree angle, The question is, what is the length of this arc? Or what's the, yeah, measure or angle? I think it's the length. Yeah, what's the length of this arc from right here to here? So the length of that arc, well, let's remember the circumference of a circle is equal to 2 times pi times r. In this case, r is 1. So basically the circumference of this whole thing is 2 pi. You guys rocking with me? All right, so now if I just wanted this portion, I only want 1/4 of 2 pi. So 1/4 of 2 pi is going to be 2 pi over 4 is going to be pi over 2. So in radians, instead of saying 90 degrees, I'd say pi over 2. Specifically in radians, remember the whole circumference was 2 pi, right? Because we're dealing with, so we would look at 360 as 2 pi. Kind of weird. We'd look at 180 degrees as, can you guess? Yes, just pi. And so this little bit of information is what we're going to use to now change the way we consider the angle measures in circles. So sometimes instead of talking about them in degrees, we might talk about them in radians. And so the relational point that we want to keep in mind is that 180 degrees is considered 1 pi in radians. So this would be degrees and this would be radians. And we're going to use this to move back and forth through degrees and radians. And finally, coterminal angles. Well, if we go back to, let me make this a little smaller. I'm going to show you exactly what a coterminal angle is. If I start off with an angle right here, and my initial ray is in green, and my terminal ray will be in blue, I could say that this angle is like 135 degrees, okay? We're looking at the degree measure. But then if I were to, and I think you probably suspected this, if I were to start here, open this angle up, go around, go up to 360 and pass it and continue on back over to this place, and I'm going to use purple to represent that terminal angle. These two angles, this 100 and the first one, which was 135, so I'll do that in blue just to honor its original terminal ray, and the other one, which was basically 135 plus 360, which is 495, I think that's right, 495 degree angle. These two angles are coterminal. They end at the same place. I know this was a long discussion, but let's just finish off with coterminal angles are angles that have their terminal side or their terminal ray in the same place once they're both in standard position. So this first problem is asking us to draw a couple of angles in their standard position, and we're going to do each of those on different pairs of XY axes. So this 240 degree angle, we remember that this is 0 degrees, 90 degrees, then 180, and then we get up to 270, and then we'd come back down to 360 if we were to keep going around. So our initial ray will start here on the x-axis going in that direction, and we're going to open this angle up until we get to 240 degrees, which would be around here. Let's think about what's happening. If this is 240 degree angle, that's what I'm representing here, then what I want you to know is that the relationship between this angle and this part of the x-axis is going to have to be 60 degrees. So in the back of your mind, you should be thinking right here is 60, and this little part right here, if you want to finish off the thought, would have to be 30 degrees. I know that's kind of tiny, guys, but hopefully it's making a little bit of sense. So that's what we have here, and what we want to focus on, I know I'm showing you all kinds of little bits of information, is just this initial ray and this terminal ray, and this arrow, which shows us the way the angle is opening up. Are you guys with me? So that is a 240 degree angle. Let's take a look at this one. So here in this example, we're going to be starting off with our initial ray as it always starts off. But instead of going in a positive counterclockwise way, where we move through the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant, this negative tells me to go in the opposite direction. So it tells me that this angle actually opens downward. And so let me get a better point on this pen. So this angle is going to open down this way, and it's going to be 30 degrees away from the x-axis over here. So in writing this negative 30-degree angle, you would literally draw an arrow showing that we're winding up in the opposite direction. We're opening up in the opposite direction than in the positive first quadrant. We're in the fourth quadrant. Finally, we're going to look at this last example where we're going to do 450 degrees. And you remember how we talked about this. We know that this is 0, this is 90, this is 180, 270. Then we come back around, this is 360. And when I add 90 to 360, I get 450. Can you guys see that? So what's happening here is that I'm totally moving all the way around. So watch this. I'm going to start off with my initial ray here. It's a positive angle, so I'm going to move like this around and then back up again. So this angle 450 is coterminal. Let me use my yellow as my final ray there. This angle that I have here that's got an initial ray that's that is red and a terminal ray that is yellow, it is coterminal with a 90-degree angle. You guys with me on that? But it went around and it opened up to this wider angle. So you all remember when we talked about radians and degrees, the fact is 180 degrees is equal to pi radians. And so we have this unique way of changing radians to degrees and degrees to radians by using this, I like to call it a gourmet one, honestly, because it really is just a number one. If these two things are equal, then the same thing over the same thing is basically a number one. So I'm going to be changing the look of these degree measures or these angle measures, but I won't actually be changing their value. So let's go ahead and practice that in this example. In example 2, we're going to rewrite the following measures from radians to degrees and degrees to radians. So we're starting off with degrees here, and we have two, I'm going to call them conversion factors. That's either 180 over pi or pi over 180. And the way we change it is we say if we're starting with degrees and we want to go to radians, we've got to use this one. We need the degrees at the bottom. So I'm going to multiply 60 times pi over 180. And what you'll notice is that technically if I had the word degree here and the word degree here, the degrees would cancel out, okay? And then what I would get is 60 over 180 times pi. And if I reduce that, I'm left with pi over 3, or 1/3 pi. And so 60 degrees is 1/3 pi in radians. Let's go ahead and change this radian measure to degree. So remember, we could either use 180 over pi or pi over 180. This is a case where we're going to use 180 over pi because we want to get rid of the radian terms, and this is in radians and so is this, and we want to be left with degrees. So I'm going to cancel out my pi values. I get negative 7 over 4 times 180. If I divide 4 into 180, will that go in evenly? Maybe. Let's see, 1640. And then we're left with 20, 25. So I'm left with 4 goes into this 45 times. 45 times 7 is going to leave us with 315, and that's negative. So this is a negative 315 degree angle. All right, I don't want to do it to you, but I think we got to do a second video. I love y'all. I'm going to see you in the next video. Bye-bye.